And welcome to our class tutorial on understanding ratios and proportions. This is going to be dealing mainly with how to extract the necessary information from a word problem and how to set up your ratios and proportions so that you can answer the questions. So, what do we use ratios and proportions for? Well, in the run of this class, we've used them for a lot of things. We've used them for looking at the cost per unit. We've used them for looking at probabilities. We've used them for making predictions. We've used them for looking at scale and size. We've looked at them for rates. Now, rates are a special kind of ratio that we're going to talk a little bit more about later on. But we've also used just many relationships between two numbers. So if we had a cost per unit, well, let me just go through a couple of quick examples here of a cost per unit. A cost per unit might be something like $5 a kilogram. All right? Or we could even have something like, let's see, $17 per 100 grams. Actually, you see that kind of thing a lot in the bulk section of grocery stores these days. Probability? Well, we could say that you have a 7 out of 10 chance of passing the test, or you have a 1 in 6 chance of rolling a 6 on a 6-sided dice. Scale and size? Well, we normally don't express those as fractions. Normally we write those a little bit differently, but say you had a map where 1 centimeter was the same as 1 kilometer. Or say you were looking at a globe where you had 1 inch is the same as 100 miles. Now, that's generally how we'll write scale and size, but again, those could also be written as fractions. Now, rates, so rates would be things like, I don't know, liter per kilometer. If we were looking at gas mileage in Canada, if we were looking at gas mileage in the United States, it would be miles per gallon. So those are a few different things that we've already looked at this year. And so let's go on. So the parts. A ratio is a fraction with a numerator on top and a denominator on bottom. In most cases, but not always, your numerator is going to be smaller than your denominator. In a fraction, the bottom number describes the whole and the top number describes the part. Now, this is true in most situations, particularly when we look at sampling and probability, but it isn't always going to be true. Times where this could be a little bit different would be dealing in cost per unit, or if we're dealing with things where we're looking at different units, so kilometers and liters, or centimeters and miles, etc. Unit rates. Those are the specific ones where we're dealing with phrases like kilometers per hour, beats per minute, points per game. Notice one word is being repeated again and again here. Per, 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 per. You almost sound like a cat, right? The word per can be replaced by that symbol, which also, if you remember, means the same thing as divide. Ratios comparing two different units. So an example of two different units, well, that's what we mentioned above, right? So two different kind of units, kilometers per hour, beats per minute, points per game. Those are different types of units. I'm just going to change my color here a little bit. Or dollars per hour. Okay? These are referred to, these as rates. We refer to these rates as unit rates, and we always want to try and make it so that we have a denominator of 1. So say, for example, 100 kilometers per hour is really the same as saying 100 kilometers divided by 1 hour. So let's do a couple of examples of unit rate. If I had 264 kilometers in 3 hours, that would be 264 divided by 3. So 264 kilometers divided by 3 hours would give us, oops, sorry about this. There we go. Bring up our calculator. 264 divided by 3 equals 88. So that would give us 88 kilometers over 1 hour, which would be the same thing as 88 kilometers per hour. Same thing if we have 3,600 liters in 20 minutes. So what we're going to be looking at is liters over minutes, which would be 3,600 divided by 20. And again, going to use our calculator. 3,600 divided by 20 equals 180. So that's the same as saying 180 liters over 1 minute, or 180 liters per minute.